Hi again, another video with more examples related to the motion in one dimension on the x-axis or on the horizontal, which is all these examples we use, it's related to real applications in our life. So in this example, I have a racing car reaches a speed of 42 meter per second. It then begins a uniform negative acceleration. Now, this is again, we have to be careful. It's a uniform and it's a negative acceleration. So it's a constant acceleration, but it's decelerating. That's the indication of these words we're using. Now, using a parachute and the braking system to come to rest 5.5 seconds later. All right, that's the time required to drop the speed from 42 meter per second to zero. Now find the distance that car travels during braking. It's not gonna stop sudden. It's stopping within a time to stop completely. So what do I have here? What I have here, that's the I have the initial velocity here. That's the initial velocity is 42 meter per second. I know that the final velocity it's going to be zero because we need it to stop. I know that the time to do the whole scenario was 5.5 seconds. Now the thing we don't know is how far this car traveled until it's completely stopped. Okay? Now, this is one of these examples I mentioned in one of my videos that you could solve the same example or the same problem in different ways. It's the way you approach or which equation you pick to help you solving the problem. Now, once again, this is a uniform or a constant acceleration, so I can pick one of the kinematics equation to solve the problem. So the easy one to solve this problem is picking that delta x equal half the, or it's the average of the velocity, change of velocity, multiplied by the time. Now this is half, sorry, it's half. Final velocity is 0 and plus 42 and the time is 5.5. If we do the math, that will give me, it took the car 115.5 meter to stop completely, or like that's the time, or sorry, that's the distance this car traveled within the braking system or within the 5.5 seconds. Okay, we could actually solve this problem in a different way using different kinematics equations. So it might be longer, but it's still correct. If you don't know how to use this formula we just used, you could do the other way, in which you find the acceleration, then you use the acceleration to find the distance uh, or the distance this car traveled during the braking. So let's do it. If I apply this formula, V final equal V initial plus a t. Now this is 0, this is 42 plus missing acceleration 5.5. Now just by doing the math, and it will be 42 by 5.5. That will give me, now it's a negative 7.63 meter per second square. Excellent. So I got the negative, which is here it's mentioned. It's a negative acceleration. Good. So I'm on the right track. Let's keep going. So I have the value of the car acceleration. Now from this, I can use it to find the distance. Now I can ignore the fact I do have the time, and I can use this one. V final square equal v initial square plus 2a and x. Now, simply, when you rearrange the formula, x will be over 2a, and the final 0 minus 42 and squared over 2 7.63. If you do the math, so 42 that will give me the same answer, 115.5 meter. So you can see from the two different methods that we managed to get the same distance. It's fine to use a longer way to solve the problem, it's okay, but if you know how to handle it faster, that means you're mastering your kinematics equation better. But still, it's the same, or it's a correct way to solve the problem, okay? So this example help you to explore a different method to approach the kinematics equation. It could be a quick equation to solve the problem. It could be a longer way where you have to use two kinematics equation to get to the answer, but it's still fine. All right, I'll try to solve in the next video another example where you could use different equations to get you to the same answer. All right, I hope you find this video useful, and I'll see you with the next one. Thank you.